Law of reflection. The angle of incidence equals the angle of reflection. This is a pretty straightforward law, but it's still very important. The idea is simple. If I have some surface and I have light ray coming in, like so, it's going to reflect. And this angle, the angle of incidence, is going to be the same as the angle of reflection. So, like I said, pretty straightforward. Now, when you're doing the problems below, there are a couple math things I want to remind you of. The first one that I want to remind you of when you're talking about triangles, remember that when you add together the angles in a triangle, they add up to 180 degrees. So that's the first thing I want to remind you of. The second thing that I want to remind you of is similar triangles. So for similar triangles, these are triangles that all the angles are the same. So all the angles are the same. So why is that important? Well, let's say I've got something like this. And we've actually used similar triangles quite a bit, both in Physics 1 and Physics 2, but I just want to really kind of clarify everything here with them. So let's say I got that one, and then let's just continue this. These probably aren't perfect, but they're close enough for our purposes. We'll say these two angles are the same. These are right triangles, so of course these angles are the same, which means these two angles here are the same. So going back to this first angle, let's just call this first angle theta. So if I've got sides, let's say A, B, and C, and this is capital A, capital B, and capital C. Okay, so that means if I'm talking about, for this, if I'm doing the sine, say, of theta, okay, then the sine of theta has to be opposite over hypotenuse. So lowercase b over lowercase c, but I got that same angle here, so it has to be equal to the opposite over the hypotenuse of this. And this is really the power of similar triangles, is that we can set up these relationships, these equalities between the ratios of the sides. I could do the same thing with cosine. In this case, I could say A over C has to equal capital A over capital C. And I could even do something for tangent. Again, same idea. Just to be complete, I'll write out tangent. So tangent would be opposite over adjacent. So there you go. So these mathematical concepts, these are going to be helpful in the problems below.